Okay, every example we've looked at so far in the class, we've always talked about Riemann sums and integrals on positive functions or non-negative functions, functions above the x-axis. What this yellow box tells us is this symbol, the integral, interprets any area that's down here below the x-axis as a negative area. Above the x-axis would be a positive area, below is a negative area. So when we're doing a definite integral, anything below the x-axis is going to spit out negative parts. Anything above will spit out positive. This total integral from 0 to 2, I can see that there's more negative stuff than there is positive stuff. The negative would win, so the total integral would be a negative number because there's more negative area than positive area. So our net area can end up being positive if there's more positive stuff. It could be negative if there's more negative, or it could be 0 if those happen to cancel out. Okay, so let's take a look at this guy. We've got the function y equals 2x. It looks like this. And I want to go from -3 to 3. I want the integral from -3 to 3 of 2x dx. Now, again, once we learn the fundamental theorem of calculus, we'll know how to actually calculate this integral using antiderivatives. But for now, we're just going to look at this using geometry. So this means the area between the graph and the x-axis, where we interpret this chunk back here to be a negative area because it's below the x-axis, and this chunk over here to be a positive area because it's above the x-axis. And we could find both of these. So this side here is side 3. My function is 2x, so this length here is 6. Same over here, this is 6 twice 3. Area of a triangle is 1/2 base times height. So this area back here, that area is 1/2 6 times 3, but because it's below the x-axis, that's a negative. And that would be -9. This area would be 1/2 6 times 3, and because it's above the x-axis, it's positive, that would be +9. So the total area would be 0. Those are going to exactly cancel out. If we were to just write the integral from -3 to 0 of 2x dx, that's just this chunk here, that would be -9. And the integral from 0 to 3 of 2x dx, that's just asking from, these are x equals here. These limits on the integral are always your starting and ending x values. So from here to here, this area is +9. The total area, then, the net area would be 0. Okay, we can play the same game here. So what I'm calculating is the integral from 0 to 6. These are x values of x minus 2 dx. And again, once we get the fundamental theorem of calculus, we could just straight up do the integral. It's not a hard integral. But in this case, we're going to use geometry. This chunk right there, a2, which is the integral from 0 to 2. Here's x equals 0, x equals 2 of x minus 2 dx, is just the area of that triangle. That would be 1/2. The base is 2, and the height is 4. But because we're below the axis, that's a negative area. And I think that would be -4. A1, this chunk right here, which we could write as the integral from 2 to 6 of x minus 2 dx. Remember, every time you write an integral, you're always going to have a differential. That's a triangle. His area would be 1/2 his base, 4, times his height. We can see there, that's also 4. Is that calculation right? Yeah, that should be 4. 6. Oh, okay, this is going to be positive 8. So my total area, or the net area, just adding up those signed numbers, which is the integral from 0 up to 6, the entire thing, would just be -4 plus 8, which is positive 4. I have more positive area than negative area, so the positive is going to win.